Okay, so we've looked at singly linked lists, and now we're going to talk a little bit about doubly linked lists. Um, and the motivation of a doubly linked list is really getting at a question we asked in one of our prior videos of why should we be limited to traversing the list only in the forward direction? And is it possible to traverse a list in the backward direction? Well, if we had pointers going both directions, not just forward, then we would be able to traverse a list both directions. We could go forward and then we could go backward. And so that would look something like I've drawn here on this slide. So let's say that inside each one of the nodes of our list, we add a previous field in addition to the next field. And now what we can do is we can start at the head and we can follow the next pointer from to the head, which is milk, and then follow next to bread, and then follow that next to eggs. And or we could follow the tail to eggs and then follow the previous pointer back to bread and then follow the next previous pointer back to milk. But then here we get to a null, so we know that we're at the end of the list. What we really have here are two lists merged together in one. We have one list going forward and another list going the opposite direction, but we keep them all bundled together. And as we think about the doubly linked list more and talk about it, these are going to be invariants that we want to maintain and ensure are always true. We want to have one list that starts at the tail and you can traverse back to the head using previous, and then we have another list that starts at the head and you can traverse back to the tail using next. Now, we can do all the same operations on a doubly linked list that we do on a singly linked list. The major change now is that the way operations are implemented will need to reflect that we have this additional previous pointer. It's not enough just to keep the next pointer up to date. Now we also need to keep the previous pointer up to date. So anytime we add or remove a node, we're going to need to update one or more of the node's previous fields to make sure that that node is linked into the previous list correctly, in addition to being linked into the next list properly. Fortunately, a great amount of the code we wrote for singly linked lists is going to work or only needs very small changes to work for the doubly linked list. And there are also some opportunities we can take advantage of. The most significant one that's obvious is that when we traverse the list, we can go forward and reverse. And now we can have iterators that go forward and reverse. Another advantage is that we can get rid of our remove after function and replace it with just an erase function. And so we can pass erase an iterator, and using that single iterator, we can erase the specified nodes and delete it or remove it from the list. And the reason that's possible now is because since we have both a previous and a next pointer, from any given node in the list, we can look and find the things to both sides of it and then fix them up to eliminate the node in the middle. And so we have some nice simplifications in how we use a doubly linked list over a singly linked list. Okay, so in summary, by adding a previous field to each node of the list, we can support forward and reverse iteration. As a result, we need to change our class definitions and operations to support it. And it's also going to allow us to make some simplifications to our interface to make it a little easier to use a doubly linked list than a singly linked list. And now we'll take a look at these implementation details.